Hey, all you sexy people. Wait, that was a different talk. This is about sexy hardware. We'll stick with hardware today. And I'll tell you soon why I'm talking about sexy. I actually think hardware is really sexy because hardware can bring us experiences for people, industry, the world we live in, right, that software can never bring us. But it will also bring us a lot more value, and way more value than we see today from the LoRa ecosystem. And that's what I want to talk about. How do we get more value out of our hardware? How do we bring it to market? How do we grow fast-growing, valuable startups? And then, what's going to drive innovation in the hardware space for the next decade? Now, I took some photos. This is just from the Things Network marketplace. And I tell you, the LoRa ecosystem has a lot of sexy hardware. And it's amazing what all the companies here have built. In fact, is anybody from one of the companies that made one of these hardware products in this room right now? Raise your hand. I bet you recognize your gadget. Not yet. You come talk to me later. There's a big blue wall outside with physical products, and I want you to go out there after this talk and look at those products and think about, is this a gadget that I want to sell for 39.99 euros? Or could this be something much more, right? Could this be part of a very valuable solution, right, that we're going to sell to a customer based on an ROI, based on the value that that customer sees from this product? This is what I want to talk about. How can we gain much more value out of all of these hardware products that we're making in the LoRaWAN ecosystem? Now, I went and took a look at the LoRa Alliance latest update for registered products in the LoRaWAN Alliance. And there's currently 382 LoRa-based products that are registered in the LoRaWAN Alliance website. I bet you there's hundreds more. So we're reaching soon 1,000 products in the LoRaWAN ecosystem, which is amazing. And there's three major things that are driving this value in hardware that I see. And if you don't remember anything else from what I talk about, these are the three things I want you to remember. First is user experience. Do we usually think about user experience with hardware in this space? No. We think about an industrial customer that needs these sensors and these interfaces and these cables. But I want you to really think about user experience for hardware. And I'll give you some examples. The second thing is hardware as a service. I think we need to get our products off of a BOM sheet. If your product is listed on somebody else's BOM list, bill of materials, you're screwed. They're going to keep pushing your BOM price down and down and down and down until they feel like you're under 10% of their product. So let's get everyone off of the BOM sheet, and let's talk about hardware as a service and the value that you can bring with hardware. And the final thing, and the thing that I think is going to drive this industry for the next decade, is personalization. How do we make your product as a service something special for each and every customer? Something different and exactly what they need. And I think this will be driven by machine learning. Now let's get back to sexy, right? I wonder if anybody can guess where my sexy comes from. And it comes from a very special man, Elon Musk, who we all love and admire as a technologist. But Elon had a plan. When he started working on automobiles, his grand plan was not what you think it was. His grand plan was this. He came out with a car called the Model S. We all know and love this. But what you might not remember is the second car that he came out with, this car, was meant to be the Model E. Except it couldn't be the Model E because Ford Motor Company, who owned the trademark for the Model E, sued Tesla that they're not allowed to use the Model E in their name. So what did Elon do? Elon said, screw you, Ford. I'm going to turn that E around, and it's going to be a 3 backwards, which is still an E. So Elon still wins. There's his Model 3. Their large-size SUV, released the following year, was the Model X. And of course, what's the small size SUV to be released next year? Is the Model Y. So Elon's grand plan with the creation of Tesla was sexy. But I think Elon's philosophy of sexy goes way beyond his naming. It goes right down to the experience of the automobile. And he's really redefined what the automobile is as a hardware object. And it's amazing what he's been able to do to a very traditional, slow-moving industry. Now, not everyone gets it right every time. I personally don't think this is very sexy. Unless you love cyberpunk and you like to dress up as a cyberpunk, this might meet your style. So think about your hardware. Don't make your hardware look like this, unless you're selling it to Blade Runner. But seriously, Tesla did two amazing things to our hardware industry, and I think it's something all of us have to try to achieve. They brought user experience into the automobile. Before this, what was user experience in an automobile? Plugging your USB cable into your car audio. Oh, and then we got Bluetooth. We could play our music on the car audio. And we finally got Apple Play in the car, which I never managed to make that work, where you plug the phone into the dash with your apps. Tesla completely reimagined what the user experience is in the automobile, and they made an automobile sexy again. This is why people buy Teslas, not because they're electric cars. It gives them the experience that they think a car should be. But there's something else that Tesla did that you don't see, but I think is equally as important. Tesla turned the automobile into a service. And I have a real concrete example. Back in 2015, Wired magazine released an article about a very special car hack. It turns out the Uconnect service that Jeep uses to connect their vehicles over cellular had a security vulnerability. If you knew the IP address of that car, you could remotely hack into the systems for engine control, steering, media. You could do anything you wanted to that car. Turn on the wipers, hit the brakes, all remotely. When that article hit Black Hat, Jeep had to recall 1.4 million automobiles and manually insert a USB stick into each of those automobiles to put a firmware update into that car to fix the bug. About a month later, it turns out that Tesla had the same vulnerability in Tesla's Model S. It wasn't wireless, it was physical, but a similar vulnerability. 1 week later, Tesla released a simple software patch as an over-the-air firmware update to every single Model S. The user simply had to say, yes, accept, and the problem was solved. Jeep got a horrible review in every part of the media. It was a PR disaster. Tesla got congratulated on the amazing service that they're providing to their users. Can you imagine that? Security vulnerability, congratulations from the media. Time magazine wrote an entire article about this. And I think that's amazing to think about what we can do with our user experience and our hardware as a service in our industry as well. Now, I had a great experience myself in user experience that I want to tell you about. Back in 2016, I had the opportunity to take a break from ARM and go help found and run this amazing organization called the Microbit. And the Microbit's a little tiny computer, have one in my pocket. This little computer that redefined what embedded development is for young people. And this little device was designed to bring invention and STEM education into every school, starting with 8-year-old kids in primary school, going through secondary school. And not only was it for kids in school, it was for their teachers and their parents. So you can imagine the user experience for this has to be really, really easy. Now, all of us embedded engineers know how hard the user experience for embedded development is, right? It's a nightmare. Tool chains, oh wait, I need the IAR and I need OCD flashing over my FTDI interface. It's a nightmare of tools and standards and interfaces that really aren't accessible for anybody outside our industry. we had the mission to go reinvent that. And we did that in a really atypical way. We did that through the BBC. So the Microbit was actually started by the BBC in the UK, and it wasn't started by engineers. It was started by people with teaching experience, psychology experience, business experience. How do you go and spread this thing throughout the entire world? And we came in as engineers to go and help them build this experience they wanted. And their vision was really simple. Let's make a web page, a web interface, that makes it easy for young people to code. Drag and drop pieces of logic. And then let's make the experience for putting that code on this device so easy that anyone can do it without training or a course. And that's exactly what we did. We invented completely new ways of doing web development, completely new ways of compiling code. We compile code in the browser so that you don't need any tools. You don't even need a web infrastructure. And then we drag and drop that code to this device. And just by making that simple device easy to use for the user group that we were aiming at, kids and teachers, and providing a really nice service, right? This was a service. This was a web page you went to and did your thing. It had course material. This wasn't a piece of hardware you bought. You bought a service for education. And the result of doing that simple thing, right, and that focus on user experience and hardware as a service was amazing. In 2016, we gave away almost 1 million of these devices in the UK. Every single child that was in grade 7 in the UK got one of these for free in school. And the BBC did research on the results of this, and incredible results. 87% of kids said they found computing, right? Working with computers and technology more interesting after they got this experience, right? We made it easier. And even more important, this is important for me, right? When we talk about technology for good, diversity and equality in technology. The other thing that we found is that there was a 70% increase in the number of girls who said they were interested to learn more about computing and STEM and invention when they got their hands on this. Because this was designed to be gender neutral. We have nice colors, we have rounded edges. We don't talk about technology in a kind of nerdy way. We talk about technology around invention. How do you water this plant? How do you measure the environment? How do you build this little doll that's a robot? You could do anything that works for anybody. And that made a big difference to how we accessed all kids that were interested in technology. And within 2 years of going outside the UK to the rest of the world with the Microbit, this little device really changed the world thanks to user experience. It's already been manufactured in millions of units. It's gone to multiple millions of children around the world in over 100 countries. And this is just an example of the activity on the website of Microbit a couple years ago. Interestingly, the Netherlands was the first country outside the UK that fully embraced and took on the Microbit. So you're going to see a lot of future kids in the Netherlands that know a lot about embedded programming thanks to this. So that's an example of how you can rethink the way we, as embedded engineers, make our technology and our hardware available, right? We should think about the target user. What do they want? What do they need to experience in order to get value from what you're doing? Rather than thinking about it from a technology point of view. This SoC with this interface and this cord, and it's not about that. It's about the experience and the value. So Microbit certainly gave us user experience and hardware as a service. And I was interested, okay, well, if we can provide this kind of new way of thinking about hardware value, what does that mean from an economic perspective? What happens when we go and create companies that sell hardware? Hardware companies aren't very valuable, are they? They kind of suck, right? They're not SaaS or software. And it turns out that's not true. Recently, I did a collaboration with a venture capital firm called Butterfly Ventures. And it turns out Butterfly Ventures loves hardware. They invest in hardware companies that use software and services and other things to make their hardware valuable. And they had a really interesting take on hardware. They said, well, yeah, it's nice, people, screens, mobile phones, software. That's all people-centric, right? But people aren't really increasing at any kind of rate any longer. In fact, population will eventually even out. And that's a good thing. But what's really interesting is the acceleration of hardware deployments in the world is dwarfing people. Already this year, we're at 31 billion devices connected in the world. That's 4 times the number of people. So another famous VC had a saying that software is eating the world. But maybe what he left out is that hardware is eating the software. In fact, in the future, you may need hardware to get access to the world at all. And that's what we're doing with sensing and LoRaWAN. We're getting communication and sensing capabilities everywhere around the world. And I think that'll make a big difference. So hardware is eating the software that's eating the world. Remember that? And we're also finding that hardware startups are becoming more and more valuable. In fact, much more valuable than people thought. The best hardware startups out there are even beating software on a very important KPI, and that's customer acquisition. So customer acquisition cost is the cost that you have to invest to get a new customer on your platform, service, product, whatever it is. It turns out that hardware startups are investing less than half the cost per customer in acquisition. And that might explain that when you look at the statistics, when startups go from Series A to Series B, VC rounds, hardware startups are more than doubling their valuation when you compare that to software startups, pure software startups. So there's a real difference that we see in valuations of hardware startups. And in fact, there's another myth where people used to think that if you put $1 million into a hardware startup, this is called capital inefficiency, you'd get a very small amount of money back. And if you put $1 million into a software startup, you'd get a very large amount of money. It turns out that's not true at all. If you go and look at the statistics again, for every single category of multiplier, so this axis below is, if you put $1 million in, you got $2 million out. And on the right, if you put $1 million in, you got more than $20 million out. It turns out for every single category, hardware is at least as good or better than software. And in fact, for unicorns that had huge returns, 20x plus, there was a major difference in the number of hardware startups that achieved that. So hardware startups are valuable, and they're competitive in high growth, high value business. But these are the startups that had their user experience nailed down, and they were selling hardware as a service. So there's some special things that they did to be this successful. Now, the final thing I want to talk about is personalization. And this is something I'm not going to shut up about for the next 10 years. I'm going to keep talking about this because I think it's so important for our field. Those of us that deal with hardware devices out there in the field. I think this gives us the opportunity to do things that the cloud and software alone will never enable us to do. And the way I think about personalization is this. Up till now, we've shipped a piece of hardware with a firmware version, right? And when that firmware version goes out there, we put that firmware on every single device of that version type that we ship out to our customers. And it does the same thing for every customer. If you want to change that, you have to do some manual configuration. But that's not how the modern world works. Think about Twitter, for example. When you're on your Twitter feed and you're looking at the latest posts, those posts are automatically adapted to who you're following, what keywords you're looking up, maybe even other information on how you behave, what you look at, what you click on. And so Twitter is personalizing that feed exactly for you. Why can't we do the same with hardware? Why can't we train a piece of hardware in a user's facility, on the user's data, on the user's behavior, to do exactly what they want to do? And I think the technological pieces are starting to come together to enable us to do that. And that's all driven by machine learning on these devices in the future. But before I go into machine learning, I want to go step back in time a little bit. I think it's important for us to understand in the embedded space where we came from to understand where we're going. And this is something that I call the 3 waves of embedded compute technology. Now, I got started in this industry back in 1998. My first project was connecting a wireless weather station to the internet using an embedded module running IPv6. We were studying IPv6 back in those days. And it turns out these embedded devices were very, very rudimentary. From the 1980s all the way through the 1990s, we basically ran machine code directly on an embedded microcontroller. We cared about safety. We cared about efficiency. And we had very simple software stacks on that hardware. Maybe an application with some drivers. Maybe not even that. Maybe the application was just bare metal. Drive the hardware interfaces directly from your application. This is how we all started, and surprisingly, a lot of embedded engineers still code like this. Connectivity, though, changed the game. So when we started working on wireless connectivity back in the mid-2000s, and of course these days, this is LoRaWAN. LoRaWAN's winning in this space. That wireless connectivity totally changed the way we thought about embedded hardware. We started to think about interpreted code, connected stacks, security, right? There's so many new things that you have to deal with when you build an embedded piece of hardware with connectivity that it revolutionized the stack. We started to have operating systems, plug-and-play modules to support these things, libraries, and even high-level scripting languages like JavaScript and Python. It's another thing that the Microbit did. The Microbit runs JavaScript and Python natively, out of the box, for kids in school. That's something we're going to see come into the embedded space more and more over the next years. So this changed embedded. It changed the entire software stack. In fact, it changed the hardware SoCs that silicon vendors are bringing to market based on our requirements. And this will continue, but there's a new wave here, and it's starting right now. And the third wave of embedded compute is all about machine learning. And what I mean by machine learning is not training machine learning algorithms on these small pieces of hardware. That's not going to happen. That's something we do in the cloud one time. What I mean is that the compute technology, right, the amount of math that we can churn out of these Cortex M4 and above MCUs is amazing. And it enables us to train and deploy machine learning algorithms right on the device. And when we do that, machine learning becomes just another software module on our hardware device. It's not black magic. It's not going to replace the rest of the software stack in what we do, but it gives us a very, very interesting way to solve sensor, predictive maintenance, classification, audio, image problems, right on the sensors, right on the embedded device at low power. And it is a perfect match for LoRaWAN. And that's why we're here talking about machine learning at the Things conference, is that LoRaWAN is an amazing match for when we can do all the processing on the device and just give the answer back to the network. So the 2020s will be all about machine learning on embedded. And I think this is going to fundamentally change most of what we do. In the end, any device that's dealing with wide bandwidth sensor data, whether it's from real-time time series sensors, audio, or images, you're going to be applying machine learning in some form in the next years. So it's something you all should be learning about. Now, together with Jan Youngboom, my co-founder, we believed in this so much, we quit our jobs and went and became startup entrepreneurs to go work on machine learning and help people get access to the technology specifically for embedded. This is something we call Edge Impulse, and we are launching this today for free for all developers in the world that work with devices. We have a launch party this evening starting at 6:30. It is a karaoke party. So be warned, you should come early. If you don't like karaoke, come early, enjoy the party before it gets unbearable. We will be trying to train machine learning algorithms on bad singing versus good singing at the party. So if you want to code when you come, you're welcome. This is a QR code with a link to the registration, so go take a picture of that and join us tonight for the karaoke launch party. Otherwise, thank you all for coming here to this event and listening to the future of hardware and, of course, sexy hardware. Thank you.
Well, thank you very much, Zach Shelby. Well, we still have ample time for some questions for Zach, if you have. We already have a question here at the front. I'll come to you. Yes. Hello.
Hi, Jack. I'm Sritam. First of all, congratulations on the new revolution to the ML on the hardware. So my question is, the inference takes place in the microcontrollers for M0 and up, but do you also plan for training it over there or training it in the cloud to get the model?
Yeah, so what we've seen is that the cloud is a wonderful place to organize the large amounts of data and the complex algorithm when you're in development phase. So we see development of these algorithms happening completely in the cloud. We're even moved off of PCs because the problem is the tool chains and the tool sets that you use, they're moving so fast that it's a nightmare to keep these up to date on a PC. So we've just moved completely to the cloud for the development and testing of algorithms. Just like DevOps, right? It's just like a CI/CD DevOps process. And what happens is when you generate the math for an algorithm, that's what we go push over a firmware update to a device, and that runs then completely independent of the internet. You don't need to communicate after that, apart from what your answer is that you want to push over LoRaWAN.
Oh, hold on.
I'm sorry. So if you get a new model trained because of some new data, you just push that small delta part.
That's right.
And okay.
Differential firmware update, for example,
Differential firmware
would work great. Yep.
Thank you.
Yeah. Anyone else for Zach? Question, remarks, theories, jokes, karaoke, anything is welcome. No. Last chance. 3, 2, 1. Okay, thank you very much, Zach Shelby.
Thank you.